Hello, today we are covering lesson 4.4, Factoring Quadratics, part 2. This is different than our previous lesson because now our a is equal to something other than 1 or negative 1, okay? Before we had a equal to 1 or negative 1, and now it looks different. I also should make the distinction that these can also not be reduced. You can't pull out a greatest common factor in any way because in this case, this term would be a fraction, and that is even harder to work with. So, when we have an a term that is different from 1 or negative 1, we kind of still use the same process as our previous lesson, where you find factors of c. So in this case, we need factors of 12. But we also, because a is no longer 1, need to find factors of a as well. So then we need to find the factors of 2. So if you look at your factor chart, the factors of 2 are 1 and 2, and the factors of 12 are 1 and 12, 2 and 6, and 3 and 4. Now, for this lesson, you're going to have quite a bit of grit and determination and a stick-with-it attitude to be able to solve these. It's not really a process that you can follow. It's more just a guess and check. There's a limited amount of things to guess, though, so it is totally possible to do. You just have to be willing to stick with it. So, if you notice, there is only one option for the factors of 2. So we still will end up getting something that looks like what we've had before. But now, instead of both of these being just x's, you get 1x and 2x. Now, this is because if you were to FOIL, you would end up getting your first term. So foiling just means you multiply each term. So we have to multiply here. You end up getting 2x squared. We know that has to happen. The same thing or similar thing has to happen with the last terms. So these have to multiply to equal positive 12. That's why we have to use one of these. Oops, mistake there. That should be a 12, not a 2. That's why you have to use one of these sets of factors in your last spot. So, in our previous lesson, it was really easy. You just found factors of 12 that would add to 11. That doesn't work now, though, because we have to deal with our number 2 here, kind of changing things up. So if you remember foiling, you have to take your first multiplied. We've done that here. We get 2x squared. You have to take your last multiplied eventually. You have to end up getting positive 12. The outside plus the inside has to add or subtract and equal this middle term. So we know we're going for something plus or minus something equals 11x. Here's where the plugging in and checking comes in. So you can start at the top and then work your way down. A lot of this you can actually do in your head. I'm going to plug it in right now just to give you an idea. So if I start with this first one, we're going to try this. We have a 1 and a 12 that we plug in. I know because this sign is positive. Let me switch colors here. Because this sign is positive, either both of our signs are positive or both are negative. And both of them have to be positive because this 11 is positive. So this sign here will be positive. We know both of these have to be positive. So if I test these guys, the 1 and the 12, I'll have to do my outside terms multiplied, so that's these two, and I will have to do my inside terms multiplied as well, so that is these two terms. Okay, so I take 12x from my outside terms, 1x times 12, and 1 times 2 is 2x, and I end up getting 14x. So those two do not check out, okay? They don't equal 11x. So let me try maybe flipping them. Put 12 here and 1 here. If I flip them, I'm still gonna have to do my insides multiplied as well as my outsides multiplied. I actually end up getting a much bigger number. I end up getting 1x from the outsides and 24x from the insides. That's way bigger than 11, so we know that this first factor actually just doesn't work. All right. The more practice you get with these, the faster you will get at them, and the less you actually have to write out, okay? So if I try 2 and 6, maybe, that's my next term, I have to take my outsides multiplied again. That will give me 6x, and I have to take my insides multiplied, and that gives me 4x. It seems closer, but it still does not equal 11x. It equals 10x. So that way, those two are not a go. Maybe I can flip them and put 6 there, my bad, and put 2 here. Yeah, there we go. I do my outsides multiplied. 1x times 2 is 2x. And then I also take my insides multiplied, and I get 12x. That's also not 11x, so these two, neither way, work once again. So let's try instead 3 and 4. So now I have my outsides multiplied. I get 4x, and my insides multiplied, I get 6x, that's 10x, oh man, so it must have to work the other way. I'm going to switch up my 4 and my 3. Let's see if this outsides multiplied, that is 3x, plus my insides multiplied, which is 8x, that finally equals 11x. So now if I was to FOIL these out, we would get back to our standard form here, and this is our intercept form. So let me just rewrite this out really quick. Our factored form of this problem is x plus 4, 2x plus 3. Now, like I said, you're going to have perseverance through these. They do get a little easier. I won't end up writing all of this down. I will show you a sort of shortcut, even though it's not really that short, of how you can find these. So let's take a look at the next one. You need factors of A, and you also need factors of C. Now, because this sign is a negative, we know that 1 is positive and 1 is negative. So we know for sure when we write out our solution, we are going to have something x plus and something x minus. Now, I don't usually put those signs in there right away because they kind of change here and there. So it really depends. So So what I do know, though, is this time 1 and 3 are guaranteed. That is like second best case scenario. If you have just one possible pair of factors, you already know that is what you need to use. So 1 and 3 are what we need to use. We're still not sure about the signs or what set of numbers is out front here. So let us check these guys. So I know either 1 and 4 or 2 and 2 will work, and we will be subtracting. Now, here's the sort of shortcut way you can think about this. You know that this is one of them we have to use, 1 and 3, and you know this is the other. So you can take different pairings. You can pair 1 and 1 and 4 and 3 together. So if you do that, you have 1 times 1 and 4 times 3. And then ask yourself, is there any way to get 1 and 12 to equal -4? Don't even include the x. If not, then you know that grouping will not be your pairing. Then you can switch it around and you can say, okay, what if I pair 4 and 1 and 1 and 3? This is just deciding your inside term. We can figure out where things go eventually. So we have 4 times 1 and 1 times 3. So 4 and 3, is there any way to get to -4 from here with any signs? There's not. So we know that won't work. Which means this grouping is no good. Let's try the 2's. Now that's actually pretty nice because the 2's you can't really flip-flop. They are how they are. So you're going to pair 2 and 1 and 2 and 3. You end up getting 2 and 6. Now, there is actually a way to get to -4 here. If you have a positive 2 and a -6. That means this grouping has to have the negative, so the 3 will be negative, while the other grouping must be your positive grouping. And then each value in front is a 2. So you've got your 2 and your 2 here. They're each individually here. And then your signs are also something you had to fill in. So your factored form here is this guy. If you checked by foiling your first times your first, you'd end up getting 4x squared. So that checks out. Then you take your outsides multiplied, you get -6x. You take your insides multiplied, you get 2x, and then you multiply your last, you get -3. By combining like terms, you'll notice that our whole problem checks out. We can get back to standard form. So that's just a way to check your work if you want to. Your actual solution is this factored form. So we have a couple more to do. We're going to do it similar. I'm just going to go through them. We need factors of 2. We also need factors of 12. I know that 1 and 2 will have to go in front of my x term in my factoring because that's my only option. I know this sign, this sign tells me that we are subtracting, so 1 positive and 1 negative. So we will go from there. Now, just by thinking through things, and in comparison to our first problem, I know that this first one's not going to work. We actually already did a problem exactly like this above, right? And we got like 20 in the 20s. And we need this to equal -5. Right here, it needs to equal that b term. So, I'm going to go ahead, I'm going to say that that one doesn't work. If for some reason you get to the end and nothing seems to work, come back and try the ones that you got rid of at the beginning. 2 and 6, same thing. I remember from my last problem that those would not have given me something that equals -5. Like I said, though, if you get to the end and you've eliminated something without actually trying it, come back, see if it actually works. 3 and 4, though, I used the last time. I also could get those smaller numbers, so I'm going to try that again. I'm going to plug in 3 and 4. Or like I did above, where I did it this way, I can group up 1 times 3 and 2 times 4. I end up getting 3 and 8. Now this can get me to this can get me to 5. So let's try it out. Let's see. Because I have 1 times 3 here, they have to be in separate parentheses. And because I have 2 times 4, for them to actually multiply, they also have to be in separate parentheses, because if you recall from above, to do the multiplication part, you had to have them in 2 different parentheses, because you're taking your insides multiplied and your outsides multiplied. And then this set, the 4 would have to be the negative term, so that way you could equal -5 right here, while the 3 is still positive. So if we check this by foiling, first you get 2x squared, that should check out, that's how we set it up. Outside, you get 3x. Inside, you get -8x, and last, you get -12. Combine like terms, and this problem checks out. You can get it back to the original. So that's great. So our factored form is this guy right here. All right, and lastly, we need factors of our A term. So 1 and 6, and 2 and 3, and factors of our C term, 1 and 5. We know 1 and 5 are our only options. So in our factors, we have something x, and then another parenthesis, something x, and then in the end of each one of them, one will have a 1, and the other will have a 5. Now, because this is a positive, we know both are positive or both are negative. But because this is a negative, we know both have to be negative. So you can actually go ahead and fill your sign in here. It's only when 1 is positive and 1 is negative that you should wait till the end. So now we have our groupings. We either use 1 and 6 or 2 and 3 with the 1 and 5. I'm just going to start with the 1 and 6. So I take 1 times 1 and 6 times 5. You end up getting 1 and 30. You know, they would both be negative, so that does not work. What then if we take the other groupings? You take 6 and 1 and a 1 and 5. Maybe you already see what's going to happen. You'd end up getting -11, so that does not equal -13, which means this first set is a no-go. Let's try the second set. If you multiply 2 and 1, you get 2, and 3 and 5, you get 15. Now, if these were opposite signs, that would be good. You could get to -13 pretty easy. But because they both have to be negative, let's actually try the flipped version. Because our signs wouldn't match up, we would end up getting -5 instead of +5. So let's try to match up the other groupings. Let's do 3 and 1 and 2 and 5. we have 3 times 1. We know the 1 is negative, and we would have 2 times negative 5. You get negative 3 and negative 10. That does equal negative 13. So those groupings match up. Now notice, because negative 1 is multiplied by 3, they have to go in separate parentheses, and 2 needs to fill in that last spot. If you check by factoring, you notice that this works out, and we get our solution there. Our factoring, actually, is what you would call it. Now we have 2 special cases. This first one, you'll notice that we can actually factor out a greatest common factor. That wasn't happening before. But we can do that this time. And then we can go ahead and factor, like we had before. Mistake there. This is a 1 now, so all we have to do is find factors of 9. This is like our previous lesson. We need factors of 9 that add to negative 6. That means they are both negative. So we have x minus 3 and x minus 3. The special thing about this guy is you notice that your factors are actually the same. That means, and on Math Excel you'll want to do this, you can write your factor with a power of 2. This is equivalent to this. Math Excel likes this guy better. Okay, that's your special case there. Your other special case is actually called a difference of squares, where you have 2 perfect square numbers. They come out to even numbers, not even as in an even number, but whole numbers. And then x squared, you can also do the same thing. The square root of x squared is actually just x. So the shortcut here, or the special case here, is you can actually find your factors with your square roots. Now notice, these are not exactly the same. Their signs are different, so you can't write them like we did over here. But you can find your factors pretty fast. This is actually equivalent to writing 25x squared plus 0x minus 49. And you can do like we did above. That would just take longer. If you know your shortcut here and see your perfect square problems separated by a subtraction, then you can write your factors pretty easy. All right, that's all I have for you today. Have a great afternoon.